At Pascal, we're taking quantum computers out of the lab. Today, we will dive into one of our key projects. Here at Pascal, where quantum meets reality, a groundbreaking journey is about to begin. This quantum computer is the result of years of research, development, and collaboration among our dedicated team. Its advanced capabilities support companies and partners in solving real-world challenges. And now, it's bound for a major institution in high-performance computing, the Jülich Supercomputing Center. From our headquarters to our customer site, this journey is about more than distance. It's about building a bridge to the future of computing.
This is a very important day for the Jülich Supercomputing Center because I'm coordinating the project HPC-QS, a European project in which we are going to integrate the quantum computer of Pascal to an HPC system, so a supercomputer. And today is really a milestone because the Pascal computer has been delivered at the GSC today. The main benefit of coupling the quantum computers and the supercomputers is that then you have the best of both worlds. So there are some, let's say, computations that we can say a quantum computer will not be efficient. So then we leave this to the supercomputer. And the thing that a quantum computer can do best, and maybe faster, or very important also, using less electrical power, can then be done on the quantum computer.
In the coming years, the technology will improve. We'll have more qubits. We will reach quantum error correction, unleashing the full potential of quantum computing and addressing more and more applications. But we will still do that with our own DNA, meaning focusing on the applications, and we'll focus on industrialization because we need to have devices that are able to be installed on-prem and which are operational 24/7.